Hello, everyone. Welcome to the 18th episode of Experience Matters. And today we have with us Dr. Angan Mukherjee. He has recently done his PhD from West Virginia University in chemical engineering, and he's doing his postdoc from Wisconsin now. So he has done his bachelor's from Jadavpur, and post which he has moved to do his PhD in US from West Virginia. And today we have with us Angan to talk about a very interesting and pertinent topic, which I feel that everybody is interested in right now. AI ML is the buzzword right now, and no better than Angan, who has been an expert in the field of AI because he has been handling and working with AI, for the last 4 5 years now in chemical engineering, particularly, and no better than him to answer all the questions that about the bubble, about the conceptions and the misconceptions of AI in the space of engineering and particularly in chemical engineering. So we have Angan with us. Welcome, Angan. Thank you very much for accepting the invitation to
Yep.
come on board. Uh,
Thanks for having me.
so I will just straight away go to you and open the forum and would like to ask you the first question, right? Ki AI in STEM, AI in engineering, right? What do you think about AI? It's a very very vast topic, and I would like you to take your time to describe what AI is and how it is relevant in STEM and in engineering.
Yeah, so first of all, thanks for having me. And I think this conversation will be quite interesting and valuable to the listeners. So, as you correctly mentioned, that AI or artificial intelligence in today's world, it's creating a whole lot of buzz. And with the not to forget the recent Nobel Prizes in physics and chemistry, there were a lot of debates on whether it should be given to something which is non-conventional or which is maybe more fundamental science, or it should be given, or like it has been given to research in the domain of using machine learning. So somewhere what you have to understand is in the in the past few decades, AI and ML has been quite widely used and has found uh, very important inroads in the field of science, technology, engineering, and maths, or STEM in general. Maybe more so in the field of engineering and technology more because we tend to use it more often than not. But even in other fields of science, you'll see many applications of AI in the recent past, starting from analyzing large complex data sets or making predictions based on past data. You can also try to automate tasks which may reduce human labor in certain applications. So let me just give you a couple of examples to uh, like just clarify how AI has changed the world in the last few years or few decades. So let's say in a proper engineering application, we both have done chemical engineering, right? So one of the most common applications that the moment we say chemical engineering, it's some power plants that you have the oil refineries, or if you have a process system, a combination of different unit operations, and you have this different types of equipments, such as a reactor, you may have a distillation tower, you may have a boiler system for that example. So, till a very long time, most of the science and engineering applications used to use the fundamental physical models that we derive from the conservation laws, we can derive from the laws of physics. And there's a term to code those. Those are called, in scientific terms, those are called first principles models. So by first principles models, what you mean is it's simply just a fancy term for the models derived, let's say, from the conservation laws or the basic physics that we have read in the textbooks. Now, till a very long time, when this advent of AI didn't take place, what used to happen was more often than not, people used to try to formulate a very complicated fundamental model for a particular system to predict its future behavior. More often, it would be computationally expensive. It may take a whole lot of resources. The prediction may not be very accurate based on the limited resources you have in computation or time, for that matter, it may take a whole lot of time to run the models. So for these kind of applications, AI actually makes life quite easier, because with the advent of AI, you can make some of these decisions in engineering or science very fast, because you can actually complement the fundamental models using past data or historical data, or even real-time online measurements, and you can actually modify the decision to be taken at the upper level for maintenance purposes. It may be for prevention of potential hazards, or just make life a bit easier and save a lot of energy and resources by being proactive and instead of being reactive.
Well, very good, constructive answer. I think you have pretty much summarized it very well in terms of the overall application of AI in how it transitioned from being prediction models and to doing larger tasks. Now we are seeing LLMs also coming in. We are seeing complex algorithms also being built in the US and used all worldwide as well, and developed by several other resources as well. So that brings to the next pertinent question, since you have already explained application in engineering, application in STEM, and application in chemical engineering also. I would go a little bit deeper into chemical engineering, because that's kind of the area of expertise that you hold as well. So I would like to know about the people who are budding chemical engineers or about to pass out. They have very much of an interest of how to use AI in chemical engineering. What is the application of AI in chemical engineering? Because they are very alien terms. When people hear AI, they mostly associate it with software, with computer science, with electronics, and very rightly so. It has a lot of applications in that domain also, but not to forget the applications that it has in core engineering. Let's say a chemical engineering or a mechanical engineering. But I would like you to delve a little deeper into the application of AI in chemical engineering. What do you think about it? What are those areas that you feel it is relevant in?
Yeah, I think it's a very nice question, very pertinent question in the field of AI and engineering. So how I see it from my perspective is the okay, at the end of the day, it's all artificial intelligence or machine learning. But if you see the applications of AI or the use of AI in, as you mentioned, fields like computer science, or let's say for that matter, even electrical engineering for some of the signal processing and transformers and other things. The use or the style in which AI is used is very different from how it is currently being used in most other engineering disciplines, such as chemical, mechanical, and other uh, core branches that we are currently aware of. Now, the basic fundamental difference comes from the fact that what is our final objective? So when you're dealing with, let's say, large language models or NLPs, or which is natural language processor. So if you are dealing with LLMs or NLPs, what you are effectively trying to do is you are trying to recognize patterns or analyze large data, and then come up with suggestions for the user. Let's say a very basic example of these type of models is any of the shopping apps you use. You just go into the app, you make some purchases, and then you just switch off the app. The next time you open the app, the all this background models has all the data they need to suggest you possible buying options. And it's on you whether you want to buy those suggestions or not, but you have the option of not buying those. So that application is pretty different from, let's say, you're working in a power plant in a chemical engineering sector, and you are the primary head of the controls there. And what you have to do is you have to let the operator know beforehand when is a valve about to explode, or when is a pipe about to explode. And you can't be like, okay, I'll give you these options. It may explode after 5 minutes. It may explode after 5 days. It may explode after 50 days. But the operator can't choose between, okay, no, I don't like 5 days. Let it explode after 50 days. So this is just the amount of risk associated with this all online applications of AI, let's say, is pretty risk like pretty high, because so far still I believe that AI is there to complement the fundamental models or the fundamental way of thinking that we have been thinking over the ages in engineering. And by over the ages, I mean since early 1900s and even till now. But what is the primary difference is the scope of AI that we use in other fields like computer science or electrical, let's say for that matter, which is mostly based on image recognition, text and visual recognition, as well as patterns, or let's say something like computer vision or image segmentation and all these applications. That fundamental application is pretty different from how you would like to use it for chemical plants, or how you'd like to use it for mechanical structures, or maybe construction works and all these things. So just to give a very, very small example, let's say for again coming back to chemical engineering. So you have some unit operation going on. Let's say you are having a lab scale reactor, and as you know, lab scale reactor will operate at a pretty controlled environment. So you will expect that the data you simulate, like we used to simulate in our undergrad labs, you, more often than not, it is to fit the actual models that we read about in our textbooks. But then if you actually go to the larger sphere of things, you will face much more complicated operations, and more often than not, the textbook knowledge and the textbook equations won't be sufficient to actually match or predict those behavior. So for those things, you can actually use or leverage the power of AI, which will still not violate the overall operational principles or the physics laws associated with the system, but you can use it in a kind of applied sense to make life easier, to make those predictions pretty fast, and in the interest of time, maybe not compromising too much on the accuracy. You can still have reliable automatic systems which will reduce a lot of risk factor and also save a lot of energy.
Yeah, makes quite a bit of sense, right? At the end of the day, it is all data that you are handling, but just different types of data and how you deal with the data and the outcome that you want to, achieve with that data. And that brings me to the next question, right? Ki, regarding all of this fuzz and all of the application around AI and ML, there is a bubble that is building up. Okay. Now, the pertinent question here is, will it the bubble burst? Is it really a bubble, or is it actual need of the hour? What are we talking here? Because we observed a similar kind of a wave back in 2015-16 with MBA. Everybody was going towards MBA. Everybody was doing, suddenly they were interested in business, 10-15 years ago. And today the bubble has burst and people are realizing that the supply is kind of more than the demand is. So do you feel that AI is a bubble, or it is here to stay in the upcoming future of the next maybe 50 years?
Yeah, I think it's a mixture of both, because you have to understand a bit of history as well. How AI came. It's not the first time that AI is introduced in the field of STEM or engineering. AI dates as old as 1960s, when we had the Hopfield networks. Then in 1980s, we had this different data-driven algorithms for fault detection and diagnosis in process plants. Then there was another kind of boom in the early 2000s, and then now. But if you ask me, I feel this particular surge of AI is much more, I would say, gives much more confidence in the ability of AI to actually contribute significantly to the world of science, if I can call that. So with the advent of some of the recent tools, such as the first thing which comes to mind is ChatGPT. I think after its advent in the last few years, it has just changed how humans think. It has just changed how humans deal with a problem. And that is the power of AI, which can be leveraged. But having said that, I think AI will reach the maximum potential if it's used to complement the fundamental physics and not replace the fundamental physics. So there's a very fine line of difference that it's really a debate whether you want to call it bubble, which is short term, or has the promise to be there in long term. But it's all depends on how effectively you use AI. There are loads of AI models, there are loads of AI techniques and tools. Not all of them fit the same application. So you need that background knowledge to actually understand which is the most appropriate data-driven or machine learning technique that will make your life a lot easier in a particular application. It's not that not all keys fit the same lock. So basically, if you're doing an application in chemical engineering, you need a specific types of models, maybe something which is much more predictive, and maybe something which is not very heavy in terms of parameters, so that if you need to retrain the model or re-estimate the parameters of the AI models, you don't take much time. So let's say I'm dealing with a process plant and I want to detect the failure in the pipeline. I should not have a model which itself takes, let's say, 1 year to simulate to give me the next prediction for after 2 months. So that is not practical. So you need to be very wise, and I mean, it comes from, I think, some part of the domain knowledge that you need to be very specific and particular about what you actually need AI to do. AI does a lot of things, but it's very important to actually filter out the most important requirements that you might be needing for your applications.
Fair point. I what I hear you saying, Ongon, is that there has been an advent of AI. It has not been something new. It's just that we have become more aware and more, driven towards this in the last past decade, if I have to say. But it has been there in 1960s, as you said, 1990s, and then early 2000s as well. I also hear you saying that it's mostly about the application of it, how it is there as an enabler to current problems and not a replacement to the current solution, but more of an enabler to the current things, right? And how one uses AI is more important. How one executes the solution of the problem using AI, that is what is going to be the game changer, and how they have the background knowledge to solve a problem using the application of artificial intelligence. That brings me to next question, which is very interesting. Okay, what do you think, down the line, if I have to predict a future, right? We see a lot of it's almost like a simulation. You said that a lot of things are predictive, but if you have to predict, right, the future of AI in engineering per se, what do you see is the roadmap 20-30 years down the line?
Yeah, I think it's a fair question because, again, I just quote anyone you ask this question to is I don't know entirely because still you have to believe that a lot of these new inventions or new discoveries using AI are still a bit uncertain going forward because I mean the uncertainty comes from the risk associated with the quality of data. Let's say you have a lot of data, but you don't effectively get a lot of information from those data. So what it means is you may have the quantity of data, but not the sufficient quality. Similarly, if you only have the quality but not sufficient quantity, you may somewhere face problems because you are not generating appropriately or sufficiently predictive models. So I think it's a bit of both, but with this recent surge of AI, I think some of the pretty interesting and there to stay kind of applications or directions that I see AI going. One of them is really this entire field in engineering called, or in AI research called generative AI. So generative AI actually lets you handle many things which classical machine learning cannot. And currently, we see AI getting incorporated in several aspects, even for mathematical modeling. Let's say if we have some knowledge about the system, we can try to append that knowledge in a machine learning model and try to come up with terminologies such as hybrid modeling, or let's say a model which is built at the fusion of AI and physics laws, and all these things. So these actually, what the difference that these kind of models make is they actually show much more promise and confidence that we are not going totally independent from how the system actually should behave by the laws of nature, but we are just using that information to append and to modify and update our AI based models such that the all the disadvantages of classical AI that you must be knowing that let's say the biggest complaint about any AI model, let's say neural nets, is that it is not very much predictive in a data domain out of the training zone. Let's say if you only train between 5 and 10 with the corresponding outputs, and you give it a input or feature of 500, it may not, or it will not predict the actual or the tentative output. So the fundamental knowledge comes from the fact that at the end of the day, AI models are parametric models. I still would love to believe machine learning as an maybe a more complicated optimization, but fundamentally there is optimization still, because at the end of the day, if you are training a regression model, you are still estimating certain parameters that you used to do in your, let's say, undergrad for linear models or quadratic models, used to estimate those coefficients. Similarly, here it's a much more complicated structure. You are handling nonlinear data, dynamic data with fast transients. So the challenges are there, but at the end of the day, it's still a parametric model. You are training or estimating some parameters to give you some outputs, which you would like to rely on to make your future decision. So I think currently with the advent of this new directions involving some knowledge from the physical systems, it actually gives a lot more confidence in AI in engineering fields, let's say particularly I'm talking about chemical or process engineering, or there's a branch called process systems engineering, which is kind of interdisciplinary, but it actually takes help from all different types of engineering branches, be it chemical, mechanical, some maybe electrical, or other applied fields like food, and you can actually have an interdisciplinary kind of framework to actually deal with all of those. So in those fields, I feel it's the promise of the current state of AI is immense. Just that it has to be used in the correct sense of it, and not. I mean, again, I would reiterate myself that it should not just try to replace the fundamental physical laws that we have in place. It should still try to complement and act as an enabler, as you said, which will make life easier.
Yeah, fair enough. I think that kind of summarizes the entire domain, right? You say that transitions will happen in the next 20, 30 years, how you see it. There will be incremental change, while some disruptive models will be built over a period of time. There will be some disruptive models that will build, and there will be an incremental on the parametric models that are already existing, solving the problems of overfitting, solving the problems of data insufficiency, and all of the other problems that you have talked about, right? So if somebody wants to go into AI ML, Angan, what are the skills that they should work on, right? Now we have talked enough about AI. Let's come to the skill set, that if they want to focus and grow in the field of AI, which are the domains that they should focus on, and what are the skills that they should prepare their expertise on if they want to pursue AI in engineering as a profession?
Yeah, I think it's a very important question as well. And I try to answer it from the perspective of a student because I have followed that path. Like I have been an undergrad student with you, I think in JU back in 2015 to 19. And then I have kind of transitioned into this research, which is still in chemical engineering, but in the domain of systems engineering, but which is much more, I would say, interdisciplinary as compared to core chemical. But from my experience, I feel fundamentally you have to be pretty confident on the fundamental skills of mathematics and statistics. That forms the building blocks. There is a lot of debate in the market around if I need to switch branches, let's say from, let's say, chemical engineering or mechanical engineering into data science and AI. Should I be taking more electives on that in that discipline? Let's say a course on data science or a course on data analysis or computer vision and things like that. Yes, you may take, but I think the fundamental importance still needs to be given to the fundamental concepts of math and stat because those are the building blocks of any machine learning or data science applications. Now, having said that, it's always nice to have a good background of programming because, again, I still believe that coding or programming in general is just a result of practice. And the more you practice, the better you become. But obviously, if you practice more, you will take much lesser time to solve problems and actually figure out what's the most efficient way to solve a problem. Having said that, I think for people actually coming from engineering background, which is mostly, I mean, honestly speaking, uh, most undergrad curricula doesn't contain any specific course of AI unless it's computer science or related fields like IT and other disciplines. So it's always nice to be aware of what is actually happening in the field of AI and machine learning in your field of or in your domain of study. Let's say if you're an undergrad in chemical engineering, it is still beneficial to see how data science and machine learning is currently being used in your field. So maybe taking electives help, taking courses to understand the fundamentals help. But I think it's really important that you understand what's actually going on behind the scenes. It's not magic. It's not robot like it's not like uh, you're having a model, you just fit some data, it's predicting something. It's not happening by magic. There is some reason how the models are predicting, and that concept comes from the fundamental knowledge of optimization, which is again applied mathematics, and some ideas of statistics. If you have to handle data, what are the different aspects that you need to see in the data, how to handle data, and then once these fundamentals are clear, then you can take all these additional training courses or tutorials for different software packages and platforms. There are a lot of things in Python Pymo ecosystem currently. You have other software packages coming up. You have so yeah, the most generic ones, if, I may name mostly MATLAB and nowadays Python. And within the Python ecosystem, you have all these deep learning packages, TensorFlow, you have Keras, you have PyTorch, and I mean, it will be a long list if I start naming each one of them. But there are resources available. So you can try to gain much more experience after following those tutorials. But at the end of the day, your fundamentals need to be clear to apply those resources in the most efficient manner.
Fair point. I think fair point on in pointing out the softwares that you would be needing. Then fundamentally, you need to be clear on where you want to pursue, what do you want to do, and which stream you want to pursue. And that brings me to the last question, the closing question, and I think the most important question: what are the opportunities in India and outside India right now that you feel are very relevant if somebody wants to pursue AI professionally?
Yeah, I think that's again a fairly good question because we all need to first estimate the future scope before taking a decision, and that's a normal human state of mind. And I completely agree with that. I think currently there is a lot of scope in this field, and I'm not saying because I've done my PhD in this field, but what I can see, how I'm seeing the research, the overall research in engineering pan out is there's a lot of potential in AI, as I've discussed earlier in this meeting, that it needs to be applied smartly. It needs to be applied, knowing what exactly you are trying to achieve. So, having said that, I think currently there is a lot of I see different new courses or electives in university setups being offered both in India and obviously abroad. I'll mostly focus on US and Canada because I have an idea about what type of courses are being offered in these places based on this AI or ML disciplines. But even in India, I see a recent interest direction getting developed in many of the IITs, and which actually deals specifically with uh, all these tools of systems engineering, out of which AI or machine learning is one of them. But even on the lines of fundamental mathematical modeling and simulation, and try to use AI to interpret certain of those experimental results that you might otherwise only could validate with experiments, but try to have all these AI-based tools to actually see whether or how far you can go in those fields. Like I see a lot of applications of AI currently in the domains of molecular simulation or maybe drug delivery. And let's say how to, there is this entire, again, an example, there is an entire AI database for AI-based database for catalyst discovery. So based on the properties of catalysts, and that makes life a lot easier because you don't have to effectively prepare every catalyst or manufacture every possible combination of composition and see how they perform, but you can actually leverage all these databases and choose appropriate AI tools to actually make a decision of how or what you want to use. There have been a lot of advent recently in this discovery of optimal networks, superstructure optimization, which is again a field of optimization where you try to find out the best connected structure possible. Let's say in a power plant where you have different unit ops connected to each other, you can still figure out which is the most optimal connection mechanism or framework to have based on the minimization of the resources and the cost and energy and maximizing profit. So you can use AI in all those fields in process controls. Again, another pretty extensively worked dimension in engineering currently, where you can use AI. And I think at the end of the day, again, there is scope. There is scope, and with more and more research, the scope will only increase. Currently, at some places, maybe there is some less scope as compared to some others, and it may just arise from a lot of different factors, not only whether people are trusting it, but from other administrative factors. There may be other factors like what is the current demand at that particular regional place or geographical location. So research is generally driven by what you want in a particular domain or in a particular location, let's say, to make that particular location ahead of others. It may be a country, it may be a place, it may be regional, it may be a continent, or it may be just the entire community, if I can call that, all over the world. It totally matters on what exactly you want to achieve, and through this research, and the more versatile and the more wide the applications are, I think the scope will only increase. And with all these new tools which is getting created, which are fundamentally different from, okay, it's fundamentally similar to a classical AI, but significantly modified from classical or conventional AI. Those actually make all this interdisciplinary research pretty common and pretty easy to grab. I think that's the final takeaway message that I'll give or try to suggest that students listening to this video is AI ML in today's world has a lot of scope, just that it needs to be used smartly and not over relied on.
Fantastic, fantastic. I think that kind of summarizes all of the queries and the possibilities of AI and the developments and the transitions. I think you fairly summarized what all skills would be needed, how to identify what all would be needed, and how to transition from a student phase and what are the opportunities in and outside India as well. And we discussed about AI being a bubble or not and what is the future of AI. I think pretty much summarizes that there is a huge scope and huge possibility of opportunities that is lying in AI. So thank you very much, Angan, for coming on the channel for this beautiful conversation. I think a lot of insights and gatherings and your wisdom from your courses and your curriculum has surely helped us. So that is it from our side for today. We will keep on bringing more experts like Angan on this channel. Just stay tuned to the channel. Thank you for staying with us. Subscribe to the channel. That's it from our side for today. Thank you very much.
Thank you so much.